Okay, we're going to do an easy one that we've done before just to get us back to where we started. And then the next screencast will be of the next 3 slides, common ion effect, with some problems about that. So, okay, when you know the KSP and you're asked for the molar solubility, that's like being asked for the number of moles per liter of AgCl that can fit into the solution. When we did this with bismuth sulfide, because of the subscripts in Bi2S3, we had these numbers here that made the ratio between the molar solubility of bismuth sulfide and the ion concentration of the 2 ions different, and so it was a little more complicated. But the nice thing about this problem is because there's 1 silver and 1 chlorine in each mole of the substance, the molar solubility will be the same as the concentration of silver, which will be the same as the concentration of chloride. But we'll still go through the steps. So we have this rice table where we have X moles per liter of AgCl will dissolve into a solution with nothing else in it. So that's when you're talking about molar solubility, you're assuming it's dissolving into plain, pure water. You guys can see the time, 7:20 Wednesday. So lots of prep on this. Okay, so if we have X of that dissolve, because it's smaller solubility, so we're assuming all of it dissolves, we have none of it left, and we have X of silver and X of chloride. Okay, so our KSP expression will be really simple. And it'll be basically X squared, and we're going to set that equal to this incredibly small KSP. You may even have this in your notes already, but this is just to do practice with a screencast. So what we get for X is, did not do this beforehand, 4 times 10 to the negative 37. Wow. And that will be moles per liter. Okay, so these expressions right here, this one, wait for it. If it's a 1-to-1 ratio, it'll always be X squared in this expression, and you can eventually skip the rice table. Okay, for this one, we ended up with 108 times X to the 5th, which is not very common. The other one that you'll get a lot is where you have like X for 1 ion and 2X for another ion, for example, with MgOH2. And in that case, the expression will be X times 2X squared. And so you're going to see 4X cubed a lot. So eventually the rice table will not be as necessary, but for now it's kind of useful just to remind yourself what's happening. And eventually also, for the common ion effect, we're not going to be starting with 0 here and here necessarily, in which case the rice table might be more useful. So for practice, I want you guys, I know you already did the homework and maybe it felt like it made perfect sense to you, but just to get even better at this, and then we'll start new stuff next time, I want you to go and try number 32, which is similar to number 31, which you had for homework. And it has 3 parts, and this expression, whether it's X squared or something else, this one, is different for each of the problems, so just will be good practice. If you don't want to do the rice table because you feel like you could jump straight to this based on these ratios, then by all means do that. And then check your answers, please. And then I'm going to ask you to submit them. I'm making a little tiny baby assignment on Veracross. I'm going to ask you to submit your work by uploading it through Dropbox, which I hope you know how to do that, because I don't really know how to explain it. Okay.